see that it goes up with considerable strength. In fact, this here is a skewer stick, and well, actually, I hope if the battery's up enough. Oh, yeah, I guess it is. Support the weight of that. And this is that's a hardwood stick, which would be comparable to a telephone pole. This thing was about 30 feet in diameter, but it's very, very little. I know a lot of people think it's ionic wind that drives these things, but you know, with this design, you feel nothing, basically nothing at all. There's so little ionic wind there, and this is quite a heavy thing, really. It's you know, it's pretty heavy. Anyway, it's leaking a little bit, but when it runs good, it doesn't leak, and it really works quite well. It uses very, very little current, and you can see it's pretty dynamic the way it goes up. Let's see if I can get a back shot here. You hear it thinking a little bit. You hear the sound a little bit better. Anyway. Like I said, there's so little ionic wind there. It's you know, you can see, but it's not even pushing down this piece of paper. This thing does weigh quite a bit, and there's you know, like if I put a piece of paper on top of it here, it has no effect on it at all. Really works quite well. I believe what it's doing is creating a gravity field above it, and it's actually trying to fall upwards. And this will go, you know, a few hours really, on this little tiny bit battery here, and it's a pretty powerful little unit. Anyway, just wanted to share that with you. Give you a little closer look at it down below on my sleeve here. So there's a lot of wood on there. And, this is actually the base. I cut this out of a pie tin, which is not really very light aluminum. Rolled over the top a little bit, and a lot of super glue and a little bit of triangular thread in the center just to stabilize the structure a little bit. But it'll do that for hours on this little battery. So I guess the next step is to build one a little bit larger with onboard power supply. This is really seems to be quite a good little power supply. A little joule thief on a flyback seems to work pretty well. Anyway.
I am here at the University of Sydney, where the mechanical engineering shop has built this incredible piece of apparatus for me. It is a 40-pound, that is 19-kilogram flywheel on the end of a meter-long shaft. Can you imagine trying to hold this out horizontally with just one hand at this end? It is impossible, okay? Now I'm gonna let go. You gonna be able to hold this at all?
Oh, I've shot.
Can you lift it out? Make it horizontal, hold it. Come on, just try to, I want you to hold it out horizontal. See if you can. Hold it. Oh, come on. Ugh. What I'm gonna do is I'm going to spin this up to a few thousand RPM, and then I'm going to attempt just that, to hold it from one end and have it out horizontally. Five, 4, 3, 2, 1, boom. I'm gonna let go with my left hand. What you'll see is that the shaft remains horizontal. You can see it going around there.
It almost looks as though the wheel is weightless. How does this work? Well, instead of pulling the wheel down to the ground as you'd expect, the weight of the wheel creates a torque which pushes it around in a circle. You may recognize this as gyroscopic precession. For a more detailed explanation, click the annotation or the link in the description to see my video on the topic. Here, I want to try something more extreme.
I'm going to try to lift it over my head with one hand while it's spinning. Wish me luck.
But before I make the attempt, Rod
What?
wisely suggests that I first check if I can lift the wheel above my head without it spinning.
Let's prove that I can lift it just this end without it spinning. Here we go. How? I mean, it's just kind of awkward with the hand.
Careful. Careful.
Woo! Just barely. Oh goodness, do you even lift? Clearly I do not.
Undaunted by my lack of strength, I'm going for it. But I want to make sure that the wheel is spinning as fast as possible to give me the best chance of success.
Give it 10 more seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, go! That was perfect. Now I am going to release my left hand and holding only with my right hand at the end of the shaft, I'll try to lift it up over my head. This is a 40-pound, 19-kilogram flywheel. Ready? Here we go. 3, 2, 1. Beautiful. Let's go again. In 3, 2, 1. Nice.
Smooth.
3, 2, 1. It feels incredibly light as I do that.
When you said it felt incredibly light,
Yeah.
when you're lifting it feels light,
Yeah,
shouldn't.
I know. Honestly, I have lifted it up with one hand when it's not spinning,
Yeah,
and it feels really hard to lift it up, like it's a
Yeah.
big effort.
yeah.
But with this, when it's spinning, it honestly felt like it was just,
Wanting to go up by itself.
yes. It felt like I was not struggling, like I was not putting in the amount of force that you think to lift that kind of weight.
I bet if you let it go, it'd crash down to the ground. It's not weightless.
We can't do that though. We can't do that part of the experiment. What we could maybe do is I could stand on a scale and we could see what the weight of me plus that apparatus does.
man who wanted to change the world.
When Sandy Kidd goes out to the lock-up garage behind his house in Dundee, he is going into a world of his own. This place has been his prison for the past 4 years. Here he has spent every minute building a machine. A very special machine. A machine which he says will open up the universe.
What I really wanted to do, I suppose, was to create the means of powering a flying saucer, that somehow I could put a machine together, using gyros, in which all the energy could be properly harnessed to produce a lifting force, or thrust, which would be capable of driving some sort of craft through space.
Like most inventors, Sandy Kidd has paid a high price for his brainchild. It has cost him over £20,000 in lost wages alone. He has turned down better jobs. He has cut himself off from his family.
Well, I got so carried away with the thing that I just couldn't help myself. Looking back on it, I don't know how I really was able to subject my family to such sacrifice and hardship.
When I was courting Sandy, we used to go to the library when we went out. My girlfriend and her boyfriend, they always went to the dancing, the pictures, but Sandy always ended up in the library. This is where we spent most of the time reading up books on science fiction. He just wasn't like a normal person. He never was.
He has what it takes to make an inventor. The French word ingénieur, from which the word engineer is derived, means an ingenious one. And Sandy is ingenious.
The ingenuity referred to by Professor Laithwaite is built into this machine. Sandy Kidd claims it is unique because it can move on its own, requiring no contact with air, water or solid surfaces. Which brings us to flying saucers. Many people are convinced that flying saucers are real and are used to transport the inhabitants of outer space between stars and planets. If these magical machines are streaking across the heavens of the universe, then one thing is certain. Their technology is far advanced on anything we are using at the moment.
My machine should be able to deliver thrust over long periods of time, years if necessary. This would mean in space travel, very, very high speeds. The acceleration of the device could also be adjusted to create an effect within the device that would simulate the conditions of gravity that are on Earth's surface. And this would completely eliminate the problem of weightlessness. Mind you, the device has other uses than taking it to Mars in 34 hours. As it says in the patent papers, it is envisaged that the device has application on land, in or underwater, and in space, which means it can be used to power submarines and ships. Might even have a flying motor car.
His obsession with this dream sustained him through the years of hardship and sacrifice which it took to turn his idea into reality. He became almost a stranger to his grandchildren, but his wife Janet had learned early on she would have to live with someone who had an inventive mind.
He was always talking about space things, science books, Einstein, Asimov, all this type of thing. I wasn't really interested at that time. I've had to live with it so long that it's just grown on me, sort of thing.
Having married a man obsessed with travel and space, Janet Kidd and her family found themselves seeing less and less of Sandy as he fell under the spell of gyroscopes.
The thing was, I still had to carry on my full-time job with an oil company in Aberdeen, leaving home in Dundee before 6 in the morning and not getting home until 7 or 8 at night. It was actually in the train that the design of the machine finally came to me.
That was around 1982, by which time Sandy had risen to a responsible job in the North Sea oil industry, earning £25,000 a year. But when he arrived back in the evenings to his home in the suburbs of Dundee, he had to start work all over again.
He used to come home from Aberdeen at night, 7:30, he'd have his tea, in the door 5 minutes, out he went. He was outside till 2 in the mornings. I just used to go away to my bed and leave him. This went on for 4 years. With no social life, we gave up all our friends. 7 nights a week, all day Saturday, all day Sunday, it was spent in the garage. He didn't have time for anything else. To me, he was just obsessed by it.
Sandy's machine is all about gyros, a gyro being anything that spins round on the end of a rod. They behave dramatically when subjected to certain forces. This gyro weighs 50 pounds and has been fired up to rotate at over 2,000 revs a minute, so that Professor Laithwaite, an expert on the subject, can demonstrate the basic concept of Sandy's device.
Very little effort required, about as much as lifting an umbrella, and no centrifugal force. Now, of course, we have the problem of stopping it.
Professor Laithwaite studied Sandy's machine at the Imperial College of Science and Technology in London. Although known as an international authority on electrical engineering, the professor's know-how in gyroscopes has always led him to believe in the concept of a machine like this, a device based on gyroscopes which could produce a genuine lifting force. When he saw Sandy's invention create such an effect, congratulations were in order.
That is fantastic. There can't be any doubt. I mean, there you go, there's a whole object that goes up. By whatever means, it goes up.
Is he the first person to have done this?
No. Others have done it, and inevitably have modified their machines to try and make them better, stop them from working, and they've never been able to recreate the original machine. I've had several like this.
So how does Sandy Kidd stand then?
Well, he didn't make the mistake of meddling with his first machine. He kept it, so that when he made a second machine that didn't work, he said, what's the difference between this and my first machine? It's only the first machine made better. Then he realized he'd lost some of the flexibility through the rather loose engineering of the first machine, and was able to see what it was that was making it go. So then he's been able to make a better machine, knowing what it is that makes it go.
It was while serving as an RAF technician on Vulcan bombers in the early 60s that Sandy first became aware of the frightening energy a gyro can store up during rotation. One day, he had to remove a gyro from the navigation system of the aircraft.
I was walking backwards down a ladder, carrying it. Unknown to me, it was still running in its box. And the thing not much bigger than this. And as I reached the bottom of the ladder and turned round, the gyro reacted really violently and threw me on my back. I was really surprised at how much energy contained in a thing about this size. I'll never forget that experience.
10 years later, in 1974, when back in Civvy Street as a development engineer, he watched Professor Laithwaite demonstrate the powers of gyroscopes during a television lecture. What he saw that evening convinced him that somehow he could build a machine to harness a gyro's energy and put it to good use.
In deciding on the basic design of the machine, I knew I had to somehow mount 2 gyros within a structure at a critical angle, and by subjecting them to certain forces through rotation and movement, produce a lifting force through the action of the gyros.
The whole machine is designed to spin round like a top, When this happens, the gyroscopes want to fly off the end of their axles because they are being subjected to what is called centrifugal force. With the gyros themselves being driven at a very high speed in a certain direction, they react to the centrifugal force by swiveling upwards and taking the machine with them. Because of its design, it is only able to rise 2 inches off the bench, but the machine is capable of climbing to any height you want. The machine produces a thrust equal to 10 or 12 ounces, but the device itself weighs 7 pounds. To calculate this lift, therefore, Sandy devised a counterweight system consisting of a piece of string attached to the top of the machine, threaded round 2 overhead pulleys, then tied to an old vise loaded with 4-inch nails. When the machine lifts, Sandy gradually removes nails until the device starts to drop. The lift achieved is equal to the weight of the nails taken away. Now, this may all seem a bit crude, but such ingenuity is the stock and trade of the inventor.
One of the most important aspects of tackling such a complex project was making all the bits and pieces necessary and juggling them around until I got everything right. Well, being a toolmaker, I could make everything myself, and that was a real bonus. I could set my own pace and get things done my way, building one machine after another, getting the size of the gyros right, mounting them at the right angles, determining the rotational speed of both the device and the gyros, so that the two interacted to create the effect I was after.
Another of his many problems was deciding how he should drive his gyros. Finally, he chose a 6.5cc water-cooled model aeroplane engine and linked it up to the bottom of his machine. This engine can produce 1.25 horsepower at 16,000 revs a minute, transmitting that power to the gyros by a belt and pulley system. The machine itself is rotated by being connected up to an electric drill.
During my experiments, I burned out more electric motors than I cared to remember about. I was stealing motors out of any gadget I could put my hands on. Washing machines, lawnmowers and things like that. In doing all this, I was working with only a very basic grasp of mathematics and physics, which of course are very much involved in this type of engineering. In developing this machine, I've been plagued with setbacks, but having been a development engineer for years, I knew full well that you rarely get anything to work first time. It was very often a question of 2 steps forward and 3 steps back. At the weekend, I simply worked on the machine from morning till night. Towards the end, I dreaded having to go out to the garage. It became some sort of hell, but I just kept going.
I wasn't happy about it, because at the beginning I didn't believe him, but he persisted, carried on with it, and it was a failure so many times, and he promised to give it up, but he never did. He always gave it a couple of days, and out he went again. And this has gone on for months and months and months. I even got it in bed at night. He brought his books to bed, his papers to bed. He sat and drew pictures to me and tried to make me understand, but I never was able to understand it. I just had to live with it.
Although the machine worked for all the right reasons, using all the factors I had built into it, the forces within the device were operating in a different pattern from what I had imagined. In other words, I had created a machine which I did not fully understand at that point, but which was producing the desired effect. It was in trying to establish how these forces and other influences were actually behaving that really created bigger problems than I'd encountered before.
Most of the people that know Sandy believe in him. They know that he'll do it. He is quite a clever person, in my eyes. Well, I see a lot of things that don't mean I do try and help him as much as I can. Gardening, decoration, painting, every job about the house I have to do on my own. He just doesn't have time for any of that. He's too engrossed in his shed with his machine to do any of the things around the house. I've gone out and left him on his own. I've packed my bags quite a few times and been going to leave, but always came back.
During the cold winter months, it became a nightmare. All my family and social obligations went by and abroad, but the loneliness of working on my own and solitary confinement was the worst part of it all. After 18 months of building and rebuilding machines, I knew I'd come to the end of the road. If it didn't work now, I knew I had nowhere else to turn. I'll never forget that night. It was November the 21st, 1984, my 47th birthday. I went into the garage, started everything up, and then it happened. The machine lifted against the counterweight and stayed up. I could hardly believe it. It was a feeling of sheer joy and relief. I'd done it, cracked it.
Throughout this project, Sandy had worked alone without help from experts, not even from Professor Laithwaite, who had inspired him 10 years before on television. Now, in his hour of jubilation, he was the man Sandy wanted to give his news to first of all.
Well, I've watched this effect for 18 months now, and I couldn't figure out what it was. But I've now proved conclusively that from 0 to 1,000 revs, you're absolutely correct in what you said.
Sandy was so obviously genuine and so almost self-effacing with what he'd done. And of course it was gyroscopes, and I asked him a few questions such as are they offset gyroscopes with skewed axes and so on, and when he said that I think, well, he's probably got the ingredient, and what does it do? And he said, well, it will lose some of its weight. And at this point you think, well, I can't afford not to see this, because I could be missing the big one. And when he was willing to bring it to me, as opposed to having me go up to North Scotland, well, of course you could come and see. I think I've got nothing to lose. I think this man's the 1 in 100 who's different. You do get a sort of feel for it. You can spot the cranks a mile off.
Reaction of the gyro, overcome the centrifugal force. There's a point where these are free flying, and I expected the vertical motion of it, and it appears to work quite well on that.
Professor Laithwaite is himself a great visionary, a man who has constantly sought to push back the barriers of technology. In Sandy's machine, he saw the reflection of his own beliefs.
And this would work in outer space as soon as it works on this beam. At the moment, the only method we know of travelling through space is by shoveling matter out of the back very fast in order to go forwards. And even science fiction writers, the people who did Star Wars, can do no better than talk about twin ion engines in which they squirt ions out of the back. They're still sending matter out one way in order to propel forwards in the shot and gun manner. Now, Sandy's machine, where it differs, is that he's produced a force by converting some angular momentum, which is easy to generate from things like nuclear submarines engines. And if you can convert angular momentum into linear momentum and propel yourself forward without shoveling material out of the back, then you could go to the next galaxy on a teaspoonful of uranium.
The professor's experience with similar projects convinced him that Sandy's idea could only be developed with proper funding. This meant contacting someone who could match bright ideas with venture capital. Such a person was Martin Rose, a high-technology consultant who chose America as the place to test reaction to Sandy's machine. But why go to America?
Well, first of all, America is the land where dreams come true. You have a film star who's now a president, so anything's possible. And logically, therefore, it's a place where a reactionless motor, which sounds like an absurd idea, should be presented. There's no problem with gaining attention. There's no problem with funding an idea like that. The key issue is its application, the verification of that idea, and who verifies it. And if you're raising money to set up a company to drive an applications development team, you have to have the right people.
The Americans recommended university research, and that is what is now happening at Dundee, where Sandy has been awarded a consultancy. He is one of a university research team trying to establish how exactly the machine is producing its lifting force and whether that force can be made more powerful. This investigative work is being carried out under some security in a small lock-fast laboratory tucked away in the basement region of the university's engineering block. Working alongside the inventor is Dr. Ian Davidson, a lecturer in mechanical engineering who specialises in dynamics.
What we hope to do is a series of tests to try and see what the overall performance of the machine is. And these will be broken down basically into an initial set of tests which will measure the sort of overall properties, followed by a series of more complicated tests which might help to tell us something about what is happening inside the machine. The first test will be some overall force measurements of the lifting effect, and we've set up a force transducer, just a little lever, and on the lever we place what we call a strain gauge, which when it's stretched gives an electrical signal, and that we can display on a counter or an oscilloscope. It certainly is a very complicated phenomenon, so it will need a bit of time before we can actually pinpoint the actual mechanism which is creating this force. It's a difficult problem mathematically, and I would have thought that it's the sort of thing that we might well contemplate as a research project for a 3-year PhD or something of that nature.
As interesting as that?
I would say so, yes.
Because the machine generates such momentum, the university authorities have insisted that it can only be run behind a strong metal guard. This caution over the safety aspect of the device is matched by Dr. Davidson's own reserve when he is asked if Sandy's machine will provide mankind with a new source of energy.
I would prefer to answer that question some considerable time later when we have a much clearer idea of what the machine actually does and the extent of this phenomenon. At the moment, it is an interesting phenomenon. Let's examine it and see what might come from it.
One man at Dundee University who harboured no doubts about Sandy's machine was Dr. Bill Ferrier, a senior physicist. Like Professor Laithwaite, he was deeply impressed with both man and machine.
Bill and I became great friends through this machine, and he often came around at night, spent many hours discussing gyroscopic theory.
The two of them would sit discussing the machine and what it could do, what it could be used for. They'd work out formulas, there'd be papers lying on the coffee table all over the settee. Eventually I gave up and went way through to my bed. But the pair of them still sat here all hours discussing the machine.
Bill was working on a mathematical formula to explain away the workings of the device, and he informed me that he was getting pretty close to putting some answers together. Unfortunately, Bill died in late summer 1986, and since then nobody's been able to reproduce his work. But Bill did leave this written endorsement of my work.
There is no doubt that the machine does produce vertical lift. I am fully satisfied that this device needs further research and development. I have expressed myself willing to help Mr. Kidd, whose engineering ability is beyond question and for whom I have now the greatest respect. I do not as yet understand why this device works, but it does work. The technological possibilities of such a device are enormous. Its commercial exploitation must be worth millions.
I have not seen anything of this type before. I find it interesting, and as a dynamicist, I would very much like to be able to track down what is actually happening.
It may take you years, but if you know you're going to get there, and you've got the patience and the perseverance, you've got all the ingredients you need.
My prediction is eventually I will win through. I've got this far. It was a struggle. I have got to assume that having got into a university establishment, that I'm winning. It's taken time, but I'm getting there. And I have got to allow the academic chappies to make up their own mind at the end of the day. Eventually, they've got to come round to the same conclusion as me.
Is it going to change the world?
I think it will, if it's allowed.
Immanuel Velikovsky, the famous Russian scientist and writer, put it this way: what I want to impress upon you is that science today, as in the days of Newton, lies before us as a great uncharted ocean, and we have not yet sailed very far from the coast of ignorance.
Okay, this is Paul, Inventor 3. This is going to be a little experiment here showing you the levitating coil over the aluminum plate. This is a scale here, just a basic scale. I want to show you a couple things here. I've got aluminum plates here. I want to show you the weight. If you can see, it's 6 pounds. Take it back off. 0. Now I'm going to show you this bottle of water here. I'm just using this, you'll see. I'm going to weigh this. That's 3 pounds. I got it. Here is the coil. It's approximately 100 windings, 650 feet, 22 gauge wire, 5.5 inches diameter from the center of the, okay, and that's like a perfect pound. So let me show you everything together. Aluminum plate, bottle, coil. All together, got 10 pounds. Okay. Now, we're going to hook up our power supply here, which is just very basic, very simple, 120 volts, 60 hertz AC here. Okay, can you see everything here? I'm going to plug this in. Make sure we got a good shot of the whole weight and the whole setup there. It's at 10 pounds. And here we go, 3, 2, 1. And you can see it's still at 10 pounds. So just to show you that it is levitation, it's not true anti-gravity, of course, but that just shows it. It's kind of neat to look at because you see something being lifted off of the table. It's not resting on there, but yet the weight is still there, the mass is still there, so it does not lose mass. So that was just a neat experiment. Just wanted to show you that. Till next time.
How much does this thing weigh?
Well, try and pick it up.
Okay.
Which is
okay. All right.
Yeah, be nice to it.
105 pounds.
105 pounds.
It consists of 4 motors connected up to these spinning magnet arrays. And if you spin these fast enough, it will actually levitate.
That's correct.
Let's see if it can do it.
You ready? Let's fire it up.
It's lifting.
Okay, it's flying now.
Is it?
Yeah, go for it. Stay on the copper.
Now it is so easy to just move around. That's amazing.
Give it a push, like it's got some real...
Wow. It could carry some weight, hey?
Yeah.
That is amazing.
So how does it work? Well, it's similar to how a magnet falling through a pipe is slowed down. Anytime a conductor experiences a changing magnetic field, electric currents are induced in it which create a magnetic field to oppose that change. And in this case, the spinning magnets induce currents in the copper sheet. They create a magnetic field which is nearly a mirror image of the spinning magnets, and so they're repelled. If the rotors spin fast enough, this repulsion leads to levitation.
That is awesome.
All right, let's set it running in.
Yep.
So it's just going to come gently land.
The induced currents then encounter resistance in the copper, so they dissipate their energy as heat.
Whoa. And this copper is pretty hot.
It's gotten warmer. Yeah, I can still keep my hand on it, at least
Yeah.
for a second or two.
But it is like a hot mug of coffee or something.
Yeah.
I experienced this before with another electromagnetic levitation device. Except with this one, the changing magnetic field was created by an electromagnet in the base, inducing currents in a light aluminum plate, which levitated.
Whoa!
The plate got so hot, you could boil water on it.
Check out how hot this plate is. If you have two north magnets facing each other,
Yeah.
they normally just kind of like fall off.
Yeah.
Is there a similar problem here or no?
Not really, no. And the reason is the magnetic fields that are induced by currents in the copper sheet are a mirror image of the applied magnetic field, and the effect is so quick that as it moves, it just kind of follows it around.
Making this device work in practice is harder than it looks. For one thing, the magnetic field of the permanent magnets has to be very strong. Neodymium magnets are strong, but there's a special configuration you can use to make them even stronger.
It's called a Halbach array. They're used in particle accelerators. They're used in fridge magnets, actually. Halbach arrays, so they're stronger on the side that sticks to the fridge, so you use less material overall.
Magnetic field lines run from north to south, and they're normally symmetric on both sides of a magnet. But if you rearrange them like this, the magnetic field lines are channeled almost entirely into one side of the magnetic array, and they cancel out on the other side. This configuration produces a much stronger magnetic field without changing the properties of the magnets. In these rotors, there are 12 wedge-shaped magnets. Their magnetic poles are fixed in this particular arrangement. This increases the magnetic field on the bottom side and almost eliminates it on the top. As the magnets spin, they create a rotating magnetic field in the copper beneath them. This induces currents that create magnetic fields, which oppose the magnetic field of the spinning magnets above. The result is a repulsive force that is effectively lift for this quadcopter. But in addition to lift, there is also drag. Energy is clearly being dissipated in the system as the heat produced by the induced currents in the copper. And that energy comes from the fact the magnetic field of the induced currents is not a perfect mirror of the spinning magnets above. Instead, the induced magnetic poles are slightly ahead. So they produce a backward force on the rotors, which is really a backwards torque. And that's why the rotors on alternate corners have to spin in opposite directions, because otherwise they would produce a net spin and turn the whole machine in one direction. This way, they cancel out. This principle has been used to achieve levitation in everything from maglev trains to hoverboards, and it's being considered as a means to make the Hyperloop, a superfast system for transporting people and goods through tubes at very low pressure. But instead of spinning the magnets, the vehicle's motion itself would cause the magnetic field to change in the conductive track below.
So in the future, you think this is going to be how we travel?
I think like ongoing developments in digital motor controllers and very powerful magnets will mean that talking about moving humans and cargo at extremely high speeds is actually something that we can, as a species, kind of look at and be like, wow, it turns out that getting from one city to another city in the same day is something that the next 1 billion or 2 billion people might have the opportunity to do in one lifetime.
first umbrella helicopter made its bow. As light as lead and cast iron could make her, this undergrown carousel was supposed to jump into the air. Try this on your next hangover.
Research began. In the 1950s, as waves of flying saucer sightings occurred throughout the United States, and while an infant space program was trying to catch up with the Russians' launch of Sputnik, a man named T. Townsend Brown was busy on experiments that defied conventional understanding about electricity, gravitation, and propulsion. Along with doctors Paul Byfield and Agnew Bonson, Brown took high voltage to the next extreme. In this rare home movie, the earliest experiments in electrogravitics are recorded. By using high voltages over 20,000 and up to 200,000 volts, Brown discovered that highly charged capacitors would exhibit a noticeable thrust in one direction. Although awarded a patent for his electrokinetic generator, no one has ever reproduced his experiment until recently. Larry Davenport, shown here demonstrating his replication of Brown's electrokinetic apparatus, explains.
But when I first began to read Brown's stuff, I didn't quite understand the difference between the ion wind devices, which there's a lot of them out there, and some of them are very efficient as far as producing ion wind, and his particular apparatus. I finally decided to do Brown's work in 1994. I looked at his device. I'd tried several different things and they hadn't worked. And I thought, well, Brown is supposed to be the pioneer of this, or so the people that make the claims and that get the patents, they always refer to his name. So I thought, I'll go back and I'll try to do this. Getting it balanced was real important.
His method of propulsion specifically was using the charge separation, high voltage charge separation on a vehicle. He found that circular craft were better for that application than winged craft. However, recently we found through Dr. Paul LaViolette's research that the B-2 bomber actually seems to qualify as an electrogravitic craft. The military has admitted that it electrically charges the forward leading edge of the wings. There's also a very high dielectric being used. Depleted uranium is used on the forward edge of the wings. And whether or not there are other applications for that technology and that design, we're recognizing that because the exhaust gas is also negatively ionized, that all of a sudden we have the high voltage charge separation that's necessary to provide an extra propulsive force, especially at high velocities. So electrogravity in that aspect is a very simple process, but does provide a good amount of force for a very small amount of energy input.
As with many other promising inventions developed during the Cold War years, the National Secrecy Act prevented scientists like T. Townsend Brown from commercializing or even publicizing any technology which could potentially be interpreted as having a military application.
A very oppressive atmosphere, an ominous feeling, a feeling as if you shouldn't even be there. It's very difficult to describe. Saucer-shaped craft
Недавно мои знакомые забрались на дамбу Гордона в Тасмании, высота которой 126,5 метров, или 415 футов. Они сбросили вниз баскетбольный мяч. Видно, как ветер слегка относит мяч в сторону, но приземляется он практически ровно, под тем местом, откуда его скинули. А теперь посмотрим, что произойдет с еще одним мячом, если его слегка закрутить.
Вау, только посмотри, куда полетел! Невероятно.
Нам что, за ним в воду теперь лезть?
Это Брэд его скинул. Я просто отпустил его, слегка закрутил, я его даже не кидал, по сути. А он просто полетел. Мы вообще никак такого не ожидали.
Настало время мне внести ясность. На наш мяч подействовал эффект Магнуса. Он распространяется на все вращающиеся сферические и цилиндрические тела в воздухе. Вот как это происходит. Когда мяч набирает скорость, воздух перед ним движется в том же направлении, что и вращается мяч. Поток таким образом обтекает его и направляется назад. Воздух с другой стороны движется в противоположную сторону, и вместо обтекания поток отталкивает мяч. В результате мяч толкает воздух в одном направлении, а воздух толкает мяч с той же силой в противоположном. Это и называется эффектом Магнуса, в честь Генриха Густава Магнуса, описавшего явление в 1852 году. Исаак Ньютон, конечно, опередил его почти на 200 лет, описав полет теннисных мячей в Кембридже. Но, знаете, в мире и так много чего в его честь назвали. Этот эффект важен для таких игр, как теннис, футбол и гольф. Но можно ли его использовать где-то помимо спорта? Возможно. Это парусное судно. Да, на парусник не похоже, однако вот эти штуки вовсе не дымовые трубы, а вращающиеся цилиндры или роторы Флетнера, которые заменяют парус. Благодаря эффекту Магнуса они отклоняют боковые ветра и двигают корабль вперед. А это самолет с вращающимися цилиндрами вместо крыльев. Цилиндры генерируют большую подъемную силу, нежели традиционные крылья, благодаря эффекту Магнуса. Однако увеличивается и лобовое сопротивление, из-за чего они непригодны. Самолет взлетел, но только однажды, чтобы разбиться. Но, кажется, эффекту Магнуса вновь нашли применение. Это экспериментальный летательный аппарат, который летает лишь благодаря вращающимся цилиндрам. А это E-Ship One, использующий 4 вращающихся цилиндра или 4 ротора Флетнера для повышения энергоэффективности и экономии сжигаемого топлива. Возможно, уже скоро эффект Магнуса будут использовать не только для запуска баскетбольных мячей.
Вау, только посмотри, куда полетел!
Переведено и озвучено студией Верт Дайдер специально для Just Video.
Of a demonstration than an experiment. What you see is the Calandra airframe mounted on the torsion balance. But there is no director fitted, or there's no torque cancellation fitted. The white disc that you see below the compeller is simply a paper sheet that closes off the aperture where the director sits. And the purpose of this experiment is to show you the effects of the motor running. There's obviously a limit to how long I can keep that running, but obviously what's happening is the motor's rotating in one direction and the airframe's rotating the other. The reason I'm running these experiments at about half power is that the motor is very small and it's struggling. It's just about producing enough airflow to provide a little bit of lift and to determine attitude control. But I think that, although I can't quantify that, clearly the angle of the blades does affect the attitude of the machine, albeit it needs to be coupled in some way via a servo.
Hi, in this video a new test with my 2004 Calandra Effect thrusters. What it does basically is suck air in and blow it over the curved surface of the disc. This causes a drop of air pressure on top of the disc. The engine used here is a cheap one from a small vacuum cleaner. As you can see, it gives about 288 grams of thrust. The engine uses 652 watts, so that's only 0.44 grams per watt. That's not enough to lift its weight, but enough to push a little car, or maybe an aircraft. More on my site at www.laserworks.com/ifo. Alright, bye. Laserworks is spelled L-A-E-S-I-E and then works.com.
What do these two things have in common? The Calandra Effect. We can use our Schlieren optics setup to actually see how the air flows past an object. Here's a cylinder, cardboard cylinder, and my source of air is going to be simply a hairdryer. And as I bring the hairdryer closer and closer, you see the flow of air is straight, but when it is close to the object itself, the air gets deflected downward. It follows the contour of the cylindrical object. When it's far away, it goes straight. This is true for any object. Here's a spherical object, a basketball. Again, if I bring the airflow close to the basketball, notice how it gets deflected downward. It tends to wrap around and follow the contour of the ball. So you notice when the air is far away from the ball, it just goes straight, whereas as I get closer and closer to the ball, it actually follows the contours of the ball and curves around. What's going on? Why does it do that? Well, we can understand it by assuming there's friction between molecules in the air. We call that viscosity. So if you assume for a moment that the air is going to go straight, and not deflect. Molecules that are sitting underneath the airflow feel a friction force to get dragged along with the airflow and leave that area, producing a reduced pressure area here. And it's reduced compared to what's up above. And so there's a net force that pushes the airflow down and it continues to curve around the ball. And that's the Calandra effect. Let's have a look at a ping pong ball being supported by a jet of air, again supplied by our hair dryer. Notice as I tilt the hair dryer, the ball remains in the stream of air and is still levitated, but also notice how the bottom of the ball is deflecting the air so it wraps around. The air follows the contour of the shape of the ball. It's really annoying when you're pouring wine and the wine drips down the side of the bottle. We can thwart the Calandra effect by making the lip of the bottle really sharp. We can do that with a piece of foil, which I'll roll up and put into the bottle, and no drips whatsoever.
So one would expect the air to flow out of the fan horizontally in all directions, but due to the Calandra effect, the air bends down to almost 90 degrees. The airflow is being pushed down by the air above, because the pressure of the air in between the flow and the curved surface is reduced by the suction of the airflow. Next, another example of the Cohen effect, where I used smoke to make the flow visible. Air is being accelerated down, and part of the upper surface is in touch with reduced air pressure. This action gives the object a force up, thrust, that can lift the object. Henry Calandra realized this and then designed a flying disc based on this effect in 1932. So one would expect the air to flow out of the fan horizontally in all directions, but due to the Calandra Effect, the air bends down to almost 90 degrees. The airflow is being pushed down by the air above, because the pressure of the air in between the flow and the curved surface is reduced by the suction of the airflow. Next, another example of the Cohen Effect, where I used smoke to make the flow visible. Air is being accelerated down, and part of the upper surface is in touch with reduced air pressure. This action gives the object a force up, thrust, that can lift the object. Henry Calandra realized this and then designed a flying disc based on this effect. In 1932,